top. So go back up to the top. So a number squared is equal to that number multiplied by itself, which is what you guys just told me. So if I have 4 squared, we can rewrite it, it's called expanded form, as 4 times 4. The little 2 to the right of the 4, so if we're talking about 4 squared, right? So the 2, what's that called? Because sometimes, oh, there it is, exponent.
I think it means it right.
It tells you to multiply the 4, called the base, 2 times. So if I had 4 to the power of 4, how many times am I multiplying 4 by itself? 4 times. Good. So the base number is the one that gets multiplied. The exponent tells you how many times. Okay. The square root of a number is a value that when multiplied by itself yields the product of the original number. So that conversation that we just had about every operation has an opposite, that's basically what that says. So if 4 times 4 is 16, the square root of 16 is 4. If 9 times 9 is 81, how do I get back to 9? 81. The square root of 81. Very good. A perfect square is a number whose square root is a whole number. It's a whole number. So that chart that I asked y'all to fill out is your perfect square chart. Because if you start with a whole number and you square it to go back, you're going to end up with a whole number, right? But this should have been 4. What's the square root of 9? 3. What's the square root of 16? 4. What gave us 5? The square root of 25. Good. What gave us 6? 36. Square root of 49 is
7.
Good. Square root of 64 is 8. What gives us 9?
81.
81. Square root of 100? 10. What's the next one after 100?
11 times 11.
11 times 11, which is what? 121. Good. Anybody know what's after that? 12 times 12, which is 144. Good. All right. So now, those are your perfect squares. If you flip over to the back, what about those that are not perfect? So we skipped around. We went 1, 4, 9, 16, 25, 36, 49, 64, so on and so forth. Does that mean that there's not value in between? What about the square root of 50? No. Square root of 50, if the square root of 49 is 7, oh, 7.1-ish, right? The calculator can give us the exact, but those are non-perfect squares, also called irrational numbers. They are numbers that are not terminating or repeating decimals. So irrational numbers. Because when you take like the square root of 50, it'll be 7.1 something, 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 something. There's no pattern, there's no reasoning necessarily behind it. It goes on, it doesn't stop, which is your terminating decimal. 1/3 is a repeating decimal, right? What is that repeating decimal? 1/3. 0.3 repeating, right? You can predict what the 10th number behind the decimal point is, can't you? What is it? 3. The millionth number behind the decimal is a 3. they cannot be written in the form A over B, which just means they can't be written as a fraction. So that means square roots of numbers that are not, what was that table showing us? What were they called again? Perfect squares. So if square roots of numbers that are not perfect squares are irrational, because the decimals that come behind all of them cannot necessarily be predicted. So square root of 3 is irrational because 3 is not a perfect square. So these questions down here, it says determine if they are rational or irrational. And what we're going to do is we're going to use an I for irrational and an R for rational, because we don't need to write it every single time. Square root of 25. 5. So would that be rational or irrational? Rational. It is a perfect square. It yields a whole number. Square root of 50. We were just talking about that one. Irrational is about 7.1, which we'll get to how we estimate that in just a minute. Why don't you guys look at 3 through 6 for me? Be careful with number 6. And we will check in just a second. Okay, square root of 2, what'd you get?
Irrational.
Irrational. 2? Rational. 50 over 8. Rational. It's not a square root. And in the definition it says they cannot be written in the form A over B. Well, it's a fraction already. So it's automatically rational. Rational. Okay, number 6, I said be careful there.
It is right.
It is rational. Why is it rational then? Okay, time out. I can't hear his response.
It can go in 16 times.
16. Okay, so 144 is perfect, right? What's the square root of 144?
65.
Right. Is 9 a perfect square? Yes. What is it? What's 12 divided by 3?
4.
Oh, so I see what you did. You did 144 divided by 9, which was 16, and the square root of 16 is 4. Either way works. Okay, so it ends up being rational. Good. So now, we've identified whether they're rational or irrational, but now, when we talked about the square root of 50, we talked about 7.1, right? Where could we have gotten that from? Why did we pick 7.1? What was the benchmark that you used to gauge how big square root of 50 was? What's close to square? Let's say again.
49.
49. Square root of 49 is right before it, right? And what's the square root of 49? 7. So if it's just one more than that perfect square, is that where that 7.1 came from? What if I had like square root of 64, right? Square root of 64 is what? 8. What if I took the square root of 63? What would you estimate it to be? 7.9. Because it's a little less than 8. Good. So to estimate the square root of a non-perfect squares, find 2 consecutive. Anybody know what consecutive means?
Twice in a row.
Back to back. 3, 4 consecutive numbers. 5, 6, 7 consecutive numbers. So let's take that square root of 63 that we just talked about. Square root of 63. We estimated it at about 7.9, right? Because it's in between which 2 perfect squares? 64 and 49, right? Because it was still 7 point something. Where did the 7 come from? About 49, right? Good. So it's in between 49 and 64. There are no other perfect squares between 49 and 64. Because what's the square root of 49? 7. And the square root of 64 is 8. There are no whole numbers in between those two. So we took the square root of each number. And then we made a decision that 63 was closer to 64 than it was to 49, right? So the square root of 63 is between 7 and 8, but closer to 8 at about 7.9. Now, if I was grading this, right, you're estimating. Somebody turned in 7.8. I'm not going to count it wrong. Somebody turned in 7.7. I'm not going to count it wrong. Somebody turned in 7.1. Would I have a problem with that? Why? It's closer. You can make more of an estimation than just putting a 7 point something. Okay? Good. Let's try one more together, and then I'll send you off on your own. Square root of 5. Between what two perfect squares? 4 and... Oh, I keep hearing 2. 2 is not a perfect square. 4 and
6.
9. Okay, where can I look if I don't know them off the top of my head?
Chart.
The chart that's on the other side. Y'all filled this chart out, right? You guys got them all right in front of you. So you filled this chart out. It's between 4 and 9. What's the square root of 4?
2.
2. And what's the square root of 9? 3. Is the square root of 5 closer to 4 or closer to 9?
9.
Okay. Well, how far away from 4 is 5?
3.
1, right? 1. How far away is 5 and 9? 4. So 1 or 4? 1. So closer to 2. So anywhere between 2.1 and 2.4 is acceptable, right? So 2.2. There is a way to estimate it even further, but after this unit, you're getting calculators, so it won't. So as long as you can tell me on what side of the half it is, then that's fine. Why don't you try number 2 and number 3, and after we check those, I will let you start your homework. Okay, so come back for a second. While I talked with a few groups, and notice that if there's mistakes, we're making all of the same one, which is actually a good thing because it's easiest for us to fix, right? This number that's inside your square root, when you refer back to your table, some of us are looking at the wrong value. We're looking at this value and not this value. If you put a list of square roots in order, right? Square root of 1, square root of 2, square root of 3, square root of 4, 5, 6, 7, 8, 9, right? Not all of those are perfect squares. Tell me which ones of those are perfect squares. 1, 4, and 9, right? So number 2, I'm looking for the square root of 3. It fell between those two perfect squares, okay? So now, when I do this, it fell like a number line, right? Your least to greatest between square root of 1 and square root of 4. And once we did that, the square root of 1 is 1, the square root of 4 is 2. A trick that everybody can use. Even though we're talking about which one it's closer to, my whole value of my decimal, remember when we were here? Even though it was closer to this, did my decimal start with 8? No, it started with 7. It starts with the lower one. So which value, 1 or 2, am I going to choose for my decimal? 1. It's always the left-hand side one, the lower 1. But then I make my observation. Is 3 closer to 4 or closer to 1?
4.
4. So it's closer to this side, which means that my decimal is larger than 0.5, anywhere from 0.7, 0.8, 0.9. Okay? Does that clarify? I know I clarified individuals, but if anybody else was having the same misconception. Okay, we're good there? All right. So then looking at square root of 10, that doesn't fall on this list, but it would be the next one, right?
Yes.
So it's in between which two perfect squares?
9 and 16.
9 and 16. Good. And we just made the observation that it's obviously closer to which one? 9. Square root of 9 is 3, and the square root of 16 is 4. My decimal becomes 3.123. Okay, so whatever you have, as long as it's less than 0.5, you're good. Okay? So now you can start on your homework, very similar to the notes.